Hi there. Today we're going to go over with section 2.8 other functions and their transformations. At this time, you should have learned already how to graph absolute value function and quadratic function. We're just going to quick review. Absolute value should give you a V shape, and you will see the value of x here could be negative or positive. That's why the domain is all real numbers. And the y from a will always be a positive because any value of x will generate to be positive from an absolute value. So the range is from close zero to positive infinity. If you remember how to graph this one, it's like a V shape. We always start the vertex, which is the origin, and then one up, one over, one up, one over, and you're gonna just do the reflection and just connect them all, and there you have it. And don't forget your arrowheads. For the square root or squaring function, it's the same thing wherein the value of x can be negative or positive, and any number that you square, whether it's negative or positive, it will produce a positive value of y. So that's why the domain is all real numbers, and the value of the range or the y can be close to zero to positive infinity. And the method the technique that I teach you on this one here is the 135. You started the vertex, you go up one over, you go up three over, and then do the reflection on the other side, and you can make your parabola. Parabola is the name of the graph or quadratic function, which looks like a U shape. Next, for cubic function, it's a same thing as x squared. You just have to multiply it three times. I'm not gonna. We're gonna go with the table here. The meaning of negative 2, if you plug in the negative 2 to the cube root there, you're multiplying negative 2 three times. That's the idea there. When you multiply negative by the negative, it gives you a positive 4. And positive 4 times negative, if you notice, the answer will be a negative again, which is negative 8. Negative 1 to the third power, or negative 1 times negative 1 times negative 1 is negative 1. 0 cubed, 0, 0 will give us just a 0. And 1 times 1 is 1, and this will also be 8. That's domain is all real numbers, and it's going to be all real numbers for the range also, because you have a negative value and positive value for both x and y. The hint that I can share to you to make it simple, we just have to go to the origin, go up 1 over 1, and down 1 left 1. And you can go negative 2 to the 8, positive 2 to the 8 there. You simply connect them. There you go. Very simple. For the square root can be positive or negative. This is similar to the parabola or quadratic. You're still gonna do the 135 here method, okay, which I'll show you more about this, how different. If you plug in the 0 to the square root, it will be 0. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Okay. Basically, this is same thing as this numbers in the table is the same thing as the numbers on the square root. If you will look at the positive value, everything right here is just the same thing as the square root. 0, 1, 2, 3, and the 149. This will be, these numbers are the same thing as this one here for the square root. Although it goes the other way around, sideways. That's why it's the same method of doing the 135 in graphing, but there's an S. The S means sideways. Let me show it to you here. You start at the origin, you go up 1 over 1. You go up 1, but this time you go over 3 to the side, to the right. Then go up 1 to the 5. And then you connect those 4 points. If you notice, it's just like a graph of a parabola, but you only consider the one of the wing. For this case, it's a positive square of x, so you only consider the above the value of the x-axis. So if this is negative here, you do the same thing, down 1 over 1, down 1 over right 3, down 1 over 5. So the graph will be just like the blue shape. On this case, we don't accept the pink and the blue because it's a function going to the vertical line test. It will fail if we apply and use both the positive and the negative. So we just have to pick one. So it depends on the question. So for this case, if there's a negative after the square root, it goes down. For the cube root function, wherein the index is 3, here the index here is 2, which is invisible 2. Here the index is written that it's equal to 3, the index. So it's a cube root. So if you will notice, this negative 81018 were the answers that we had for the cubic. So it's the opposite or reverse way of the cubic function. So basically, we expect this to be the y value in our cube root function. So this should be negative 2, this is negative 1, 0, 1, and 2. So cube root and cubic function are going to be same thing. If the cubic function is something like this, the cube root is just like this. It's the same way, although this goes sideways. So let me show it to you here. So you start the origin, go up 1 over 1, up 1 to the 8, and down 1 left, down 1 to the 8 there. So just have to connect those 5 points and just make sure that it goes smooth like that. Okay, very simple. Okay, let me skip that one and let's go with the transformation. So we know now that the y is equal to, let's go first with square root of x. It's the same thing as the 135. So you go up 1, I go to the vertex, go up 1 over 1, go up 1 over 3. 3 points is good enough, okay? Remember, you have to be familiar with the function and its graph, including the transformation. So this is the parent function for the square root of x. So if we add y is equal to square root of x plus 5, we should know that the graph is gonna go, all these 3 points will go up by 5. So this one here will go up by 5 here. Or you can apply the 135 from here. Go up 1 over 1, up 1 over 3. And the graph will be like that. So if we combine the horizontal and vertical transformation, let's say if I have x minus 2 here and I have a minus 3 here, the minus 2 is inside, so I'm going to go sideways, left or right. But since it's minus 2, I do the opposite one. I go to plus 2 and then down 3. So that's my vertex, that orange point. And I can do the up 1 over 1, up 1 over 3, and just simply connect them. Now, if we decide to have a negative, let's say this blue one here, y is equal to negative square root of x, let's say plus 4 plus 3 here. So the plus 4 is inside, so I go left 4 and up 3. And this is my vertex now. Since this is negative, the value of y will always be negative, will turn to be negative or going down there. So I have to go down 1 over 1, down 1 over 3. And I just simply connect them, and they're moving towards a negative value of the y. So that's for the square root function. If we're doing the cube root, so cube root this time, cube root of x, you should be familiar that the cube root of x goes something like a letter S with a smooth, okay? And let's make it simple here. The parent function goes like, go to the origin, 1 up, 1 over, and those on the left one. This 3 1 is good enough, okay? But you have to understand that on the 8, it goes to the 2 here. On the negative 8 goes to there. That's good. And I can erase this 2 points here, but just make sure that when you graph it, you don't do it this way. This is the wrong way. You connect them and then it's all right. That's good. You do this one, you're wrong. That's not the ideal one here. I would like you to imitate and copy this one as much as you can. This kind of graph here. Okay. So let me erase that one again. So the graph to do this one here is, you don't pass the negative 2. Okay. Because you expect to have a graph here. So you can just pass this one here and connect them and make it smooth S curve. That's good for me. Okay. So if you have the y equals cube root of x plus 4 minus 3, which is the same way the movement of the horizontal and vertical shift like the other functions. The plus 4 is inside, we go to the left 4 and down 3, 1, 2, 3. So this is the transformation from the origin. So you go up one over, go down left one, and again don't pass the next line there. So you can just assume the graph goes this way here, and make sure you don't pass to the negative one. So just keep it like that. Very simple, right? So if we do the cubic or cubic, okay. So this one here is the same thing as the cube root, although it's a standing cube root function graph, something like that, standing up. Same thing. You go in the origin, go up one over one, down one, left one. Same thing. Although you don't go sideways, you go up and down. So you don't pass the negative two. You go to somewhere here, make your arrowheads, just connect them. That's right. That's good to me. Do not. What you don't need to do is like you just put any random arrowheads and then you connect them and then that's it. No, that's wrong way to do this because you pass the negative two or the positive two. So the blue one there is wrong. So don't copy it. Okay. Now it's the same thing. Transformation y equals x, say parenthesis minus 5 cube, then say plus 2. So the negative 5 is inside. So you go to the right 5 and then up 2. So that's your vertex. Basically, go up one over one, down one, left one, and don't pass this point here. So you go just somewhere right here and connect them, and don't pass the 7. So you go that way. Boom. Very simple, right? I hope you understand now how to graph these five functions and what the graph looks like, and together with the transformation. Okay, kaboom.